Hi there. Today I'll be presenting an experiment that achieves a stage 2 material world outcome, describes how adding or removing heat causes a change of state. Students will have a developing understanding of this topic, and this investigation will look to build on their current knowledge through a hands-on task and the incorporation of digital technology. To successfully complete this experiment, you'll need the following equipment: a heat-resistant flask or beaker, a measuring cup, balloons, a stovetop or heat map, a timing device, and the application measure, which is found in the utilities section of the App Store. When preparing the equipment for this experiment, I would suggest using a flask or a beaker that has a small opening. This allows the balloons to fit over it easily without stretching them and breaking the balloons. As the nature of this experiment involves manipulating heat and hot surfaces, additional safety equipment should be utilized when conducting the experiment. This involves protective eyewear, a lab coat, and tongs to be used when moving the beaker off and on the stovetop. In my experiences, this experiment can be done in two ways, of both equally valued to the students. The first is by the teacher solely conducting the experiment and the students observing. The teacher then asks prompting questions along the way to get the students to the desired learning outcomes. The second is by the students breaking into pairs or small groups and having additional teachers following them and supervising to ensure safety. The method you choose to use will be dependent on the resources available to you at the time of the experiment, and also knowing your students and what will work best for them. The students should be engaged and excited in the topic from previous lessons, and now it's time for them to explore the topic further. This will be done through introducing the digital technology in the start of the lesson, where they can explore the changes of state through this simulation. The digital technology extends the learning possibilities for the students as they are able to manipulate the variables found in the simulation to better visualize the different states of matter. Students then have the opportunity to hear from their educator. They can bring questions to them and use the educator's expertise to clarify the concepts being found in the simulation. With this fresh in their mind, it is now time to start the experiment. Pose the question to the students. Is it possible to inflate a balloon with only the equipment found in front of you? This line of questioning should invoke critical thought within your students and open dialogue. It is your job to facilitate these questions and bring them to the conclusion that it might be possible if we add water and heat. Here you can see the different variables of the experiment. The independent variable is the temperature of the stovetop, as that's what we'll be intentionally altering at the beginning of each task. The dependent variable is the size of the balloon, which we'll measure at the end of each task, and the controlled variables are the things that will remain constant between each task. The control of this experiment is a balloon placed over the top of a flask with no added heat to the stovetop. This is to be used as a tool of comparison for later findings. To start the experiment, grab a balloon and place it over the top of the flask like so. The next step is to adjust the stovetop heat to the desired temperature. In this case, we're just using the settings 1 through 6. Set the timer for the experiment to 3 minutes and off it goes. Once the time is up, remove the flask from the heat and record any changes to the balloon size. Follow the same process for the next experiment by adjusting the temperature up 1 notch. Now that the timer has gone off and there's an observable change in size of the balloon, record this change with the application measure and record these findings to a piece of paper to be put into a table at a later date. As you continue changing the temperature and recording the changes seen in the balloons, encourage the students to ask more questions on why that the balloon size is changing. Hopefully they'll see the correlation between the balloon size and the temperature change. Refer back to the simulation that the students engaged with and encourage them to think what might be occupying that space. The greatest change in balloon size was seen as the temperature was set to its highest level. This is due to the rising temperature of the stovetop and in turn moving the water from a liquid state to that of a gas. As the water molecules move faster and turn to a gas, the balloon is filled up with those particles. This experiment further achieves the outcomes found in the syllabus point, as students can see easily what happens to the water molecules as they are removed from the heat. The water molecules move from a gas state back to a liquid as the temperature cools, and as such the balloon will deflate. Also, if you were to put the same balloon back on the stovetop, it would inflate again. Exploring the phenomena in this way will hopefully solidify why it happens in the students' minds. Once the students have tested all of the different stove settings and the correlating balloon size, they can input this data into the digital technology of Google Sheets. Here they can alter the X and Y axis in order to produce a chart that will easily display their information in an appropriate manner. Students can then display this information through the application iMovie, in which they can also commentate over their findings. Additionally, the website Scratch offers the students an opportunity to visualize their findings through the use of coding and animation. This additional opportunity for students to evaluate their findings also allows them to build upon coding skills that are becoming more common in the primary school setting. Upon completion, students can accumulate all their findings and upload them onto YouTube. From there, they can put their URL into a QR code generator in which it will be developed, and they can share their findings easily with their friends, peers, and wider schooling community.